Today's topic is functional independence. It's a very important topic. Functional independence is found in different components of module or in different modules. Two types of functional independence are found. The first type is called cohesion and the second is called coupling. What is cohesion? Cohesion is the measure of relative strength of a module. This means cohesion is the strength of module. Cohesion is the bonding or relation of different elements inside the module, while coupling is the measure of relative interdependence among the different modules. This means coupling will always exist in different modules. Minimum 2 modules are required for coupling. You can see the first figure. This is module A, and these are the 4 different elements of module A. So what type of independence this is? This is the cohesion. So when the number of cohesions increases, the strength of this module A will increase, while module A is in couple with module B. Always remember that we will need less coupling and more cohesion. If the software have more coupling as compared to cohesion, so that is the bad approach of designing. While if the software have more cohesions as compared to the coupling, this means the cohesion to coupling ratio is higher, so that will be the good design. Cohesion is a relation of different elements of the same module. As I stated, strength of module is defined by the number of cohesion included in a module. So try to strive for a high cohesion. There are different types of cohesion: functional cohesion, sequential cohesion, communicational cohesion, procedural cohesion, temporal cohesion, logical cohesion, and coincidental cohesion or least desirable cohesion. So these are the 7 most found cohesion inside the module. Let's come to discuss about the functional cohesion. Functional cohesion contain elements that all contribute to the execution of one and only one problem related task. This means all the elements combinedly work for a single purpose and single task, execution of single problem. Or we can say that for the execution of particular task, we need all the elements or particular number of elements, specified elements should work together in combine. So functionally they combine and then task is performed. In short, all the elements of module are grouped together to achieve a single purpose. Examples of functionally cohesive modules are: compute the cell tax. How cell tax is calculated? Cell tax is calculated on the basis of this cell. So how cell is computed? So this will require the different elements, like from different invoices we will need different product quantity and their prices along with the discount, and they all executed combinedly compute the cell, and on the basis of cell then tax is calculated. We have a predefined slabs for the different cells and then cell is calculated. Similarly, when we want to compute the net salary include the basic salary, the allowances, the bonuses, the leave taken, etc., etc. So this also include the functional cohesion of different elements. Similarly, calculate the cosine of an angle. So cosine of an angle is computed from the direction of the particular side with the x-axis and y-axis angle form, and then cosine is calculated. So functional cohesion is required and is most desirable. Another type is sequential cohesion. The name indicates sequential. This means the output of one activity will be the input for other activity. Remember the activity. When one activity finishes, its output will be the input for another activity, and so on. For example, module read and validate customer record. So for validation of customer record, first the record should be read. So this is the activity 1, and then validated. So without reading, it cannot be validated. So the execution is in sequence. Another example is product read. Product is first read from the database and then add to the cart. If it is available, then will be added to the cart. So reading, validation, and then addition to the cart. This is another example. Another example is file upload takes place in the following sequence. When we want to upload the file on the Google Drive or any drive, or want to send in some communication medium, file reading from the folder. This is the first activity. First it will read the file. If it exists, so the next step will be taken. If does not exist, so it will wind up. The second activity is the file formatting. So after reading the file from the specified location in the folder, the file will be formatted and then it will be compressed. Why compressed? For better efficiency and for fast transfer of data, and for the utilization of resources, we need a compression, and then file will be uploaded. Similarly, ATM cash withdrawal works in the following sequence. Card verification. First, your card will be verified if it is expired or not. If it is expired, this means it will not function. If it is okay, then the pin will be verified. Balance verification. Then your balance will be verified. If you have efficient balance in your account, then your transaction can be successful. Then if balance is okay, enough, sufficient for withdrawal, then maximum amount per day verification. If you have entered the amount greater than the maximum amount you can withdraw per day, so it will be verified first, and then it will check either the enter amount is the multiple of 500 or not. Then you can withdraw the money. So all these are the examples which are executed in the sequence. Remember that all these are inside the one module, like ATM transaction, one module, and the purpose of that module is the money withdrawal or money transfer. File uploading is a one module. File customer record validation, customer product order, etc. These are all the tasks belong to one module, and inside the one module all the activities are executed in a sequence. We have another type of cohesion that is called communicational cohesion. Communicationally cohesive module is one whose elements contribute to activities that use the same input or output. If the module has different elements that have been grouped together because they access and modify the same data structure, it would demonstrate a communicational cohesion. How? Suppose we wish to find out some facts about the book. For instance, we may wish to find the title of the book, price of the book, publisher of the book, author of the book. Remember that all of these include the same book. So book can be searched with the title, with the price, with the publisher, author. All will search the same book. The same book. So if we search by title, price can be computed. If we search for price, so different title books can come. So this means they are all in cohesion. These all attributes are in cohesion. But what type of cohesion? Communicational. They all are related. Each identify other attribute. These four activities are related because they all work on the same input data. The book. The book is the same input, which makes the module communicationally cohesive. Another example is that module determines customer details like use customer account number to find and return customer name and loan balance. If you visit some branch, bank branch, and you don't know your account or you have forgotten your account number, so you give your CNIC number and they find your account number. Or if you give your account number, your all details, name, CNIC number, balance come. So this means all these attributes are in cohesion. And what type of cohesion? Communicational cohesion. Another example, let's see. Module which produce employee salary report and calculate the average salary. This is report 1, which is employee salary report, detailed report and average salary. So this required produce employee salary report and calculate. So these two functions are required for these two reports, and both of these use the same salary table. So if we know the salary report, we can find the average salary. So this means from this same input, we have originated the two different reports. This means there is a communicational cohesion in the different attributes of the salary table. Procedural cohesion. In a procedural cohesion, elements or tasks within the module are grouped according to the sequential execution, such as module that perform a series of interconnected procedures in particular order. Procedural cohesion says that parts of the module are grouped because they always follow the certain sequence of execution. It sounds similar like the sequential, but there is a difference. In sequential, one whole activity executed, and then the output of that activity is the output for another activity. Here, different elements or different parts, programming statements, procedures are grouped together in sequence, and they combinedly as a group execute. Remember that in functional cohesion, sequence is not necessary. Maybe the elements or parts are executed in sequence but not mandatory. But in procedural cohesion, all the procedures, statements are executed in sequence for achieving the execution of one particular task. For instance, consider a function that may collect an employee name, address, and phone number in that specific sequence because it matches the way the user is asked for the information. For example, on the input screen, so a module demonstrates procedural cohesion when its elements are grouped based on the sequential execution. So all the data will be retrieved and will be displayed in sequence. Another example is module that averages two completely unrelated tables. Execution is based on the two unrelated tables. Execution of particular task and activity is based on two different tables. Let's say table 1 and table A and table B, which both just happen to have 100 elements each. So let's come to discuss this. Module compute table A average and table B average, uses table A and B. These are two different tables. Return table A average, return table B average. Table A total is equal to 0, table B total is equal to 0. We will use for loop for I is equal to 1, for I is equal to I to 100. Add table A I to table A total and add table B I to table B total. So table A will be added, all the rows will be added to this table A total, which is initialized as 0 and similarly table B rows will be added to table B total, and then it will be divided by 100 to take the average. So this start here and end up here. So we need both of these tables for the particular activity. Similarly, you can take example of C++, a simple example. When you want to calculate, you want to compute some problem. So first step is the declaration, initialization of variables, and then you take output, and then you put some formulas in sequence. If you don't put formulas in sequence, so it will not be executed. So procedural cohesion include different statements in sequence. Temporal cohesion. A temporally cohesive module is one whose elements are involved in activities that are related in time. Means they are very loosely coupled. They only combine when are needed. Temporal cohesion exists when the tasks in a module are exist in the same time span. For example, a function which is called after catching an exception, which closes open files, create an error log, and notify the user. You know that exceptions are the exceptional cases, such as divide by 0, array bound exceed, string size exceed, etc. When you enter number instead of character or character instead of number. So exception arises and it is called. But it is oftenly called when needed, not all the time. So this is the temporal cohesion. So the functional cohesion, which is called after catching an exception, which closes the open files, creates an error log, and notify the user that you are closing the open file. So exception is called. That is the temporal cohesion. Second example is the set of functions responsible for initialization, startup, shutdown of the some process, etc. So when you start up some program, when you shut down some program, some process, so set of some functions are called, and then they are called again when we need it. Logical cohesion. Logical cohesion is when the parts of the module are grouped because they are logically categorized to do the same thing, even when they are different by nature. A logical cohesion is when the parts of module are grouped because they are logically categorized to do the same thing even though they are different by nature. This means the different elements are not physically in cohesion, but are only logically connected. How? Take this example. A module maintain employee master file. If the input flag is 1, means if we select some one particular option like radio button 1, so what will happen? Add a new record to master file. If we select option 2 or input flag is selected 2, so what will happen? Delete an employee record. And if we select the flag 3, option 3, then edit employee record. Similarly, we take example of searching. If we select flag 1, customer, for example, student ID, so it will search the record on student ID. If we select the flag 2, which is the contact number, so the record will be searched by the contact number. And if we select address and name, etc., so will be searched accordingly. So this means they have no physical relation. Searching is different, but logically they are connected. Coincidental cohesion, which is the lowest or least desirable cohesion. A coincidentally cohesive module is one whose elements contribute to activities with no meaningful relation to one another. For example, a utility class can be an example where the elements within it are completely independent of each other. If we take Java utility class, so there are different utilities, libraries, each have different purpose. So they are coincidental cohesion. This is the decision tree for a module cohesion. So this is very important and interesting. You will check this decision tree decide which type of cohesion takes place or which type of cohesion it is. So you will check, does the module do anything? This means do the module perform anything? If yes, so it is a functional cohesion. If no, if the module is not doing one thing, this means it is no. So we will check how the tasks are related. This means the module is not doing one thing. So three possibilities. The first is belong to the data. Is the sequence important in the data? Yes. If it is yes, this means it's a sequential cohesion. This means it is not a single task, but rather there are multiple tasks performing by the module. Task 1, when performed, the output will be the input for the another task, and the output will be output of that module will be input for another task, etc. Is the sequence not important? Then it is a communicational cohesion. What is communicational cohesion? You have already seen here that they use the same data. Now check the second condition, flow of control. Is sequence important? If it is sequence is important, this means it is a procedural cohesion. So what's different between procedural and sequence in this context? Here there is a sequence in the data. This means data is passed from one activity to another. Here there is no sequence in data, but a sequence in the control. When one element is executing, then there is a sequence inside different procedures. So it is a procedural cohesion. If it is no, then it is a temporal cohesion. And temporal cohesion is when The elements are linked together for the time being. Neither it is a flow of control and neither it is a data in sequence. So we will check, are these tasks related to the same general category? Yes, it is then the logical cohesion. No, it is the least desirable coincidental. So this means they are not belong to a same general category, like we took example of utility class and different libraries. So are the tasks related to same general category? Yes, then it is a logical cohesion. So there is no physical cohesion but are belong to the same general class. So this was all about the cohesion in detail. In next lecture, the coupling types will be discussed.